What is up, guys? I'm hoping that you're good. Back with another repair. I'm pretty sure you guys know this one. I did a video about a motherboard similar to this, same to this actually, same as this, which had a dead PCH, which meant there was no way forward. Anyways, I managed to get this board. I'm hoping that maybe I can fix this one. So what's the issue with this one? Yes, the typical plug. How do I do this? Okay, let me just take it off from the stand and then record that side. So I've got the typical plug and AC adapter, and I've got a short. I'm going to saw that, and I'm plugging the charger at the same time. Yes. Why do we have two ends? So you can see the moment I'm plugging the charger, I've got a short circuit there. Got a red light and it's drawing a lot of current. Current that it wouldn't even draw if it was charging and playing a video game at the same time, because these are not that great. Anyways, let's see what's happening. We've got a short circuit, so let's try and figure out where that short circuit is coming from. So I can see, remember when you get to take note of two coils like this, you've got your 5 volts and 3.3 volts in one place. So they're usually in one place. What I'll do is, okay, I can see there has been some liquid on this board. You can see that. Well, I'm still hoping that it's fixable. Anyways, let's check. We've got like 5, 6 and rising. Oh no, that was 53 kilo ohms actually. And we've got 312 ohms on this one. So this is a little bit suspicious. Seems very low to me. And this one has got like 12 kilo ohms, 13 going up. Anyways, those are secondary power rails. Let's check the main power rail. Oh yeah, we've got a short circuit on the main power rail. That should be ground, and that should be the main power rail. We've got like 0.6 ohms. So let's see visual inspection if I can pick something that's faulty. Not really. Of course we've got corrosion there, but that's on top of the graphic card. It's not on the PCB itself. Alright, on this one we have to do voltage injection. And I know for a fact my thermal camera is not charged. Charge. Okay. Oh, it's actually charged. Would you look at that? It's on 70%. Okay, I'm just gonna plug it to the charger just to keep it charged. I don't know what's happening with this cable. It's charging and stopping at the same time. Anyways, that's besides the point. Let's fire up the short killer and inject voltage into this motherboard. So I'm gonna kind of zoom out a little bit so that the whole motherboard comes into frame. That way we can be able to spot where we are getting heat from. All right. So this is pretty much the whole motherboard, as you can see. Let's inject voltage. then try to locate our short. Okay, definitely our short is coming from somewhere here, somewhere there. We've got like 40 degrees there. The rest of the motherboard is like 23 degrees, 40 degrees, right next to the CMOS connector, somewhere here. Okay, 40 degrees is a lot. I should feel some heat. Is it at the back? Interesting. I do not feel any heat at all. I couldn't feel any heat. Let me check this side again. Okay, so I can inject somewhere over there. Let's see. Let us have a look at this side. Okay, so it's this one. We're drawing like 3 ohms and it's gone. That short circuit is gone. I hate short circuits like this. They just increase in resistance. They don't disappear. Pretty much related to something which is around here. Not sure if we should rain dance around it. Yeah, let's do that. Let's do that because this is, as much as it's a main power rail, it feels like it's also, I don't know, it feels like it's kind of a secondary power rail. Let me see what components do we have that we can take off. So we've got the 0.06 this side. Oh, it's back. That short circuit is back. Oh, this side we've got 3 ohms. So this is not where we were supposed to be injecting. Anyways, lucky enough we were injecting only 1 volt, so shouldn't have done anything to anything. Let me inject one more time. Try to have a more clear view of where that heat is coming from. So I don't want to increase any voltage because we've got pretty good resistances there. Okay, 1 ohm current draw. Okay, here's the thermal camera. Let's inject. It's gone again. Why are you being a pain in the item? Let me check one more time. Do we still have a short? Yes, we do. We've got 19 ohms. So what I'll do in this case is I know it's somewhere around here because that's where we were getting our pretty high resistance. So what I'll do is I'll take that MOSFET off, those caps off, or rather let me just isolate the short man. So lucky enough, this is our main power rail, I believe. Let me just confirm. Yeah, this is our main power rail. So lucky enough we've got a jumper connection over there. So we can always isolate, see if our main power rail is gonna have a short circuit cleared by just removing that part. I need to remove that tip of the braiding hook. makes it difficult. Let me add my melt solder to it. There we go. It's very important that you know which side is temperature sensitive on your soldering iron. Some of them, they are only hot at a particular corner, like just a small piece of the corner. Wow. 10 minutes trying to eliminate a short circuit on the main power. This is new. Okay, I've got those isolated now. Let's check if we still have got a short circuit on the main power. So we still have a short this side, we no longer have a short this side, meaning this side we are good. So our short circuit is coming from somewhere around here. Let's just check the output, what resistance we're getting there. We've got 18.6 ohms, which means this MOSFET is dead. If we probe across that MOSFET, we should be getting 0 ohms. Let me see. Yeah, 0.6 ohms. We've got 0.6 ohms. So let's take that MOSFET off and pray that the secondary power rail that it powers didn't fail. So when a main power rail, when a MOSFET which is on the high side of a DC-DC converter fails, there are some slight chances that before it failed it fired 19 volts into whatever it was supposed to fire, 1 volt or 2 volts or whatever into. So it gets a bit tricky, man. It makes you uneasy. Okay, there we go, the MOSFET is off. The atmosphere is off. Let's check what are we getting now. We are no longer shorted, so it wasn't no cap, it was not a capacitor, it was the MOSFET. Alright, we still have 18.18 ohms over there. Let's check the MOSFET again. Yeah, MOSFET is dead. It's got 0.8 ohm resistance across it. 1.1, 1.0, so this MOSFET is dead. Let's replace it. Let's replace it and see if we're lucky. I'm gonna use that motherboard as a donor board, the one I was serving the other day. Oh. Right. You don't do the same. Let me see if I can grab another one. You also don't look the same. Not the same board, but they pretty much work the same. Anyways, I'm just under the impression that I'm just working under the assumption that, not the assumption, the fact actually. That's a secondary power rail, so we've got two MOSFETs working around there. One high side MOSFET and one low side MOSFET. So I'll replace both of them. The low side of that power rail is on the other side of the motherboard. So I'll start with this one. Okay, let's go. Cool. We still don't have a short circuit, so we're good. We might as well replace that jumper over there. I know the low side MOSFET is not faulty because we do not have a short on this power rail, but nonetheless I'm gonna measure and perhaps change it. Let's see. Got 19.3 ohms across it. That is probably 19.3 ohms because of the output side, how it's supposed to be. So let's do this. Let's take this MOSFET off because they go hand in hand. That's the low side of the circuit. Okay. Still gonna get the same resistance really, but we'll have eliminated the chances of the circuit failing again due to a MOSFET that was about to fail, because usually they affect each other. So there we go. What resistance are we getting? Yeah, 20 ohms. Just checking something over here. Something's wrong. Got 20 ohm resistance there, yet on this motherboard it's got like 400, 500 and rising. So we've got an issue somewhere over there. This motherboard which I'm comparing with switches on but it doesn't display. So considering that this is dead, we shouldn't be getting that much low resistance over there. Therefore, let's take this component off, because that's the controller which controls those two MOSFETs. And check the results. What are we getting now? We still got 23 ohms. We still got 23 ohms, which is rather strange. What else could be related to that area? The output, it's only the output that's related. Could be there, because the output becomes the input of this particular circuit, I think. Let me see and confirm. Okay, this is powered by a 5-volt power rail, so it is not related to this. This output is coming here specifically. I don't know where else it goes from here. There's no board view. I tried to look around by board view, but yeah, let me just go like 1.5 ohms over there. It's 0.3 there. 0.1 actually. This feels like a dead PCH again. Let's check with this one. 1.4. That's fine. Yes. Alright. Should we try our luck as it is? Let's see what resistance we're getting over here. Those two caps there. Got like 42 kilo ohms. So our issue is here, guys. No. Oh, fine. This is also 42 kilo ohms. Huh. I'm gonna guess things are okay here. Pretty low, but me put back the chip, the controller, and we test it out. I'm not happy with the resistance really, but let's see. Let's reduce the airflow, that way we don't blow the component away. That looks fine to me. Yep. Looks okay. Just for sanity's sake, we'll just run the soldering iron on the sides. Let us fire up this thing and hope for the best. Fingers crossed. What do we get? We no longer have a shot. The device has responded to power. Let's try to go for the power button. This should be the power button, I think. Oh, we've got a fan spin. And it's showing 0.29 amps. I've been chasing my tail. This thing had been fixed already. That low resistance didn't mean anything really. There you go. This is fixed. And we do have an LED. It was under this. I don't know why it was under that. Anyways, this is on. Do I have a RAM on it? No, there's no RAM. Let me grab it. PC3L, because I know these ones they need PC3L, and then we can test it out. So the owner of this laptop actually needs it working. Reason being, as much as it's an old device, it's got a GPU and it's got touch screen. So yeah, back in its day it was a really good laptop, I guess. Alright, give me a picture. I'm not so happy about my RAM slots there, but we'll just hope it's not a big deal. So the other thing that I need always with this is the speakers, because I need to hear what the motherboard tells me in case there's any error codes. It always beeps. So I'm expecting 5 beeps because there's no CMOS battery on this PCB. Okay, I've got 250 milliamps and it's still jumping around. Let's see if it's gonna restart at 300 now. What are we gonna get? Give us picture. I'm not liking this. It's on, it's running, but it's not going on and off. It's not basically restarting. It's supposed to restart. What could be the issue? Maybe the BIOS maybe the RAM. Got fan spin only. No speakers playing anything at all. Possibility that these speakers are faulty. The current draw is kind of increased now. I'm gonna try these speakers because that other motherboard which I was talking about, that it's on but not display, I was also expecting it to beep but it didn't beep, so it's possible that these speakers are faulty. Let me try these ones. No beep from the speakers, only an increase in current draw. So at this point, what could be the issue? Could be the BIOS. I don't know. Let me manually restart it. I've switched it off. I'm gonna switch it on my second time because it's supposed to automatically do it 3 times. But I've had scenarios where I had to switch it off, switch it on, and then switch it off again. The 3rd time it displayed. So I basically done the reset manually. Still the same behavior. That moment when you think you are done and then you realize you still have some work to do. Anyways, we'll figure this one out. We will definitely figure it out. Okay, let me do it the 3rd time. There you go, that's power off. Let's go power on one more time and expected display. Fan spin. I know this RAM works because I tested it on a Dell, an E7440. Those ones are very notorious. They don't just give display. They need specific RAM, so this RAM worked on that one, it should work on this. Same behavior and no beeps. Got the keyboard over here. I'm just gonna plug it to see if maybe I've got a caps lock. Nope. No caps lock. Alright. Let me rather go for BIOS on this. So this is what I'm gonna do. I'm gonna pause the video because I don't think I need to record a video of me taking off the chip, putting it on a programmer, waiting for it to read, flash a new file, go to the second chip, do the same thing. That's quite unnecessary drama. Let's try a different RAM slot. Clean the RAM slots and then, yeah, try it one more time. Here's my toothbrush. I've got some alcohol here. Because remember there is some dirt around the RAM slot. Okay, yeah, let's try it one more time. So this is PC3L 2 gig. should work. Okay, I've got power one more time. Now it's a little bit different. The current draw is a bit different. It's lower than the last time. That was like 27, 28. Now I'm getting like 22, 0.22. Let's wait for it, because it's dancing around. It's going up and down. Okay. So there's still some chances that this might display. Oh no, I know for a fact that it will display if it restarts. But if it doesn't restart and keeps dancing around like that, it won't display. It will be stuck here for a very long time. One thing that we could do is we could check if we've got an voltage output around that coil. The very same coil that we just fixed. This one. It's just something interesting to consider. So as you can see, we do have 19 coming in, but we've got 0 going out. We have got 0 volts going out. What do you think is the issue? Could it be that the controller is faulty? Here we should be getting like 5 volts coming in. Yeah, 3.4 volts coming in. 1.9 going out. 1 volt, 1.1 volts going to the RAM. This is our main power. We need to check there. Bias chip is getting 3.4 volts. That's fine. What else? This is going to our PCH, 1 volt. CPU is not gonna get anything really, because we don't have an active motherboard. 1 volt over there, and this one, which was low resistance, got 0.1 ohms. This might be the issue really, because that was very low resistance. Let me show it one more time. Now it's pretty high. That's fine. Alright, before we blame the BIOS, let's just do one more thing. And where is the tip for the screwdriver now? I have to use the manual screwdriver. And it's fine, I won't die. Okay. Just want to check underneath the heat sink to see if maybe I've got some corrosion or something like that. Nope. Seems all good. And this is an AMD motherboard. Looks like an AMD motherboard. Okay, not sure about that. Let's go for the BIOS. Let's go for the BIOS. That's probably the next move. This is 902. This is 9901. Alright. I'm gonna pause the video, check off this chip, check off that chip, reprogram them, and then put them back. We'll see from there. Yeah, the spell continues. I've reprogrammed the BIOS and I've reprogrammed the EC with files that are known to be working. Well, still got the same result. We still have the same result. So yeah, the only thing that I can do at this moment is change that component, this one. So this, you can see the fan is spinning, got a light there, and based on the power supply there, I know I don't have a display. I didn't even have to check because it's doing exactly what it was doing before. So what I later on did was I mistakenly powered it on without the heat sink, and I just realized the CPU and the graphic card are not even getting hot at all. They are just off. So I don't even know what it is that's drawing 200 milliamps. Okay, got the AC LCD in. I'm just holding the PCH to feel if it's the one that's drawing 200 milliamps. And it's not even getting hot. So what is getting hot? Nothing is getting hot, but something is drawing like 200 and something milliamps. There has to be something getting warm. That's a lot of current, man. Well, let's change that component. That is our last resort at the moment for now. If we change this component, we still don't get a result. Yeah, I will have to forfeit for tonight and accept losing the battle, not the war, but the battle. That looks like it's in position, so I can bring the soldering iron against it just to make sure the pins are connecting there. Okay, there we go. AC adapter, what am I getting? Still the same. Oh no, it's not the same. It's not the same. Suppose you get a display of like 700 milliamps. Okay, let's wait for it. This should display now. Oops. Stuck. That is wild. Why are you stuck in one position? Like, jump around at least. It's just stuck. Let me get a set of speakers and see if we can listen to an error code or something like that. Oh, we've got an error code. That's 5 pips, which means CMOS battery missing. Now we've got an error code. I've never been excited to listen to hear an error code. Let me see if I've got a CMOS battery that is having like 3 volts. This one has got 2.8. I'm pretty sure it'll work. Let me just try it. Okay, let's see. Power on. Wait, showing this. Which one? Oh, there we go. It's on now. Did we get any error codes? Still getting 5 pips. The CMOS battery is too low. Give me a minute to check a new battery and then test it out. Okay, I've got a cell CMOS battery with 3 volts in it. 3 volts to be exact. I'm hoping it's gonna work. Otherwise it needs 3.3 volts. Let's listen for an error code. Still giving me a 5 pip code. Let me try to get one with 3.3 volts. Okay, so I've taken out. Oh, there we go. Huh. Finally. So I ended up having to do this. I can't find a single CMOS battery in the shop, so I have to order in the morning because right now it's like 4:15 a.m. So yeah, it's like in a few hours. I mean, anyways, there we go. Got a picture. Let's see at wattage cannot be determined. What? Huh. You should stock up when it comes to CMOS batteries. Turns out I had to increase my hours spent on this by almost 20 minutes. What was it, 20 or 15? Looking for a CMOS battery because I finished this a long time ago. Okay, I'm gonna try to restart the device. No response from body keyboard. Let me use an external one. So I'm gonna restart this. Okay, I've got power. Should get picture. Just wanna see the specs. And why am I not getting any response from the external keyboard? Don't tell me we've got issues with the USB and stuff. I'm gonna try the internal keyboard one more time. response. Just wanted to see the specs. So it's an i7 3rd gen, and this person only loves it because it's got a touch screen. I'm sure it works when in Windows or something like that. Anyways, yeah, that's it for now, guys. I've spent 45 minutes on this thing, 45 minutes and 36 seconds. That's a lot. What did we do when we first got the motherboard? It had a dead short circuit, which was being caused by a faulty high side MOSFET right over here. So we changed the high side MOSFET as well as the low side MOSFET, and then we managed to get the short circuit off, switched it on but not display because we didn't get an output over here due to a faulty controller, integrated circuit, that one, PU300. So after removing PU300 and replacing it, we managed to get power and an error code but not display. That was because of CMOS battery. So 5 pip codes, that's a faulty CMOS battery. Anyways, I had already tried reprogramming the BIOS and the EC chip, but there wasn't a need for that. Anyways, I'm hoping that you guys enjoyed the video and that you learned something from this. That's it for now, guys. Cheers and goodbye.